differentiable means not kinked. It means continuous and not kinked, and not vertical. So precisely what we're doing is, okay, so first of all, precisely why we typically assume things aren't kinked is to make the math easy. Precisely what we're doing when we say, yeah, but actually they are kinked, is we're making the math harder. And precisely the way in which we're making the math harder over and over and over again is that we're creating piecewise utility functions. This is a piecewise utility function, okay? Because it has a different functional form above and below the kink. Now, we've seen in all three of the problem sets, and it is not unreasonable to suppose that we may see again on the midterm, a situation in which you are asked to either maximize a piecewise utility function or set something like g to an indifference point where the utility function is piecewise. In this problem, we didn't have to worry about that, right? Because this side of the gamble was guaranteed to put her into the domain of losses, and this side of the gamble was guaranteed to put her into the domain of gains. But in part D of the problem set, where you're asked, in C of the problem set, she's gone into the domain of losses, and you're asked what g will make her indifferent. Well, if she's in losses, we know that losing 5 more is going to keep her in the domain of losses. But if she's $10 into the domain of losses and we give her g, some arbitrary number we haven't solved for yet, is that going to put her into the domain of losses or not? Is it going to put her past her kink? Which part of this piecewise utility function is it going to require us to use? The technique for answering these questions is always the same. It was the same when we were asking about labor supply relative to an indifference curve, where we were actually doing calculus first-order conditions. It's the same when we were figuring out buying and selling prices. It's the same now when we're figuring out these indifference payoffs, which is first you have to figure out the conditions, right? So you're solving for g. You first have to figure out the conditions on g that determine which part of the utility function you're going to be in. So let's rewrite this problem so that it reflects C. If this was C, then this would actually be the value of losing 10 relative to a reference point of 0, or taking a gamble in which you lose 15 relative to a reference point of 0, or you lose 10 plus g relative to a reference point of 0, right? Okay? And so what we don't know is whether 10 plus g is greater than or less than 0, because the kink is at the reference point. So what we don't know is 10? Minus 10, thank you. Minus 10. So what we don't know is whether g minus 10 is greater than or less than 0, which is another way of saying we don't know whether g is going to be greater than or less than 10. That's the first step in getting this stuff right. Okay? There's some variable you're solving for. In this case, it's g. But in the second problem set, it was, I can't remember if I said h for hours or l for labor, h. And then earlier there was one where I think on the first problem set you were solving for a buying price or a selling price where you didn't know if it was going to go above or below 0. I may be wrong about that. First, figure out what you're solving for and what condition on that variable determines the breakpoint in the utility function. Okay? Now what you're going to do is you're going to have the case where g is less than 10 and the case where g is greater than 10, or equal, but almost always, well, in this class, the utility function will always be written so that if g is right at the breakpoint, it won't matter. Sorry, if g was right at 10, it wouldn't matter which piece you were in. So first go here and figure out what is the set up the utility problem. Set up the utility with that condition. Okay? If g is less than 10, then g minus 10 is negative. That puts us into the domain of losses. We'll use this part of the value function. Write it down. Write down this problem with v being in the domain of losses. Okay? Then solve for g, and then check. Does my solution satisfy the condition? Now, in the problem set in part C of problem 1, when you plug in the value function in the domain of losses and solve for g, you got a g of something like 3.45 or something like that. I can't remember. And sure enough, that's less than 10. Now, you may be tempted at that point to say, aha, I have found the solution. And that's not correct. What you have found is a solution. Okay? So you know that when you're maximizing a mathematical function, it may have one solution or it may have two solutions. Okay? So you have found one candidate for the solution. So then go ahead and do the same thing for g greater than 10. And what you find is that when you write it down with the utility function for g based on g greater than 10, and then solve, you get a g of, I think, 9.02, something like that. And then you check. Is that greater than 10? No, it's not. This solution is no good. Now you're done. And if they both work, okay, then you just look and you say, well, which one actually has the higher utility? Okay? No, I'm sorry, you wouldn't in this case because there's indifference, so it's not a question of higher utility. You know they have the same utility. So if there's two, then you just write down the two solutions. There won't be. But what if neither of them work? Hang on one second. What if neither of them work? Right, so in problem set 2, what we had was not setting up an indifference condition like this. What we had was first-order conditions. And the first-order conditions had a kink, right? So not even a kink. There was one set of first-order conditions for one part of the problem, for one part of the utility function. There was another for another part, and it depended upon what the slope of the revenue function was. But you do exactly the same thing. Figure out the conditions that you're solving for h. Figure out the conditions on h that define the breakpoint between the two pieces of the utility function. Solve for below the breakpoint and check to see if your solution is below the breakpoint. Solve for above the breakpoint. Check to see if your solution is above the breakpoint. What happened in that was it didn't work for either of them. That should be a clue that you need to look at the breakpoint itself, because that's the only thing left. If you've already checked everything below the breakpoint and everything above the breakpoint, like one of the nice things about the real line is that it's only unidimensional. So if you check everything in this direction and everything in that direction, you can stop checking. You know that you are at the breakpoint. So, any questions about this? There was a question here, yeah.
So since you're in the domain process,
yeah.
Say that G must be less than 1.
Yes, you could say that. That would be a perfectly legitimate argument. Tell me your name again. Pedram? So Pedram said, since we're in the domain of losses and there's diminishing sensitivity. Now wait a minute, is that right? We know that going 5 down is going to hurt less than going 5 up because of diminishing sensitivity in the domain of gains, losses. So what Pedram is saying is, okay, if we've gone down into losses already, we know that going down more is going to hurt less, like going down 5 is going to hurt less than the benefit we get from going up 5 because of diminishing sensitivity. And if we're trying to find the g that makes her indifferent between staying right here and losing 5 or gaining something more, what we want to find is the g. Literally what we're doing in this problem is we're finding the g. So if we take this little vertical distance here, go up there, go over there, that's g. And yes, you can logic your way to figuring out that it must be less than a gain of 5. And then you don't have to check this side. But if that doesn't occur to you, I want you to have first principles to fall back on. I want you to have the Bob the Builder way of doing it. Okay, any other questions about? Yeah.
Just looking at in general, it starts with calculator, goes away any type of calculator.
Any type of calculator. Yeah. I mean, I would recommend one that's easy to use because you're not going to need complicated functions. So yeah, I mean, just a basic scientific calculator will be fine. Okay. Are there any other questions? Okay. So where have we seen this? I've talked about it already. Buying and selling prices in the endowment effect, whether or not to take a gamble, which, by the way, is largely the same question in a lot of ways. Right? Whether to take a mug or not, whether to buy a mug or not buy a mug, is actually a choice between gambles. They happen to both be certain gambles. There's no uncertainty, but the math is exactly the same, okay, as choosing between gambles. And then how much labor to supply, which is not a yes-no choice, but a continuous choice. And I've sort of talked a little bit about how that requires you to then figure out first-order conditions, which are going to be defined in a piecewise manner. Okay, so this is I'm taking a slightly scattershot approach in this outline. Another topic that we've talked about, though maybe not so obviously so, is the question of endogeneity and confounds. So one of the things that I personally really appreciate about psychology and economics is that it's a subfield of economics in which people are taking the scientific process a little bit more seriously than perhaps in some other subfields of economics. Experimental economics is another, and this is part of the reason why people sometimes lump experimental economics together with psychology and economics. It's not explicitly because we do a bunch of stuff in the lab. It's because we're actually taking seriously this idea that you should test your theories rigorously to see whether or not they're correct. Okay? So what we look at, now all economists look at questions of endogeneity and confounds. I think I'm just emphasizing them a little bit more in this class than might be the case in some classes, although labor economics is probably the other place where you would see this stressed the most. So endogeneity, when we're trying to prove something scientifically, and we have some test, typically some kind of econometric test using observational data, like maybe we've got a bunch of data on cab drivers, labor supply, right? Endogeneity, what we're trying to prove over and over again, is that one thing causes another. So if I'm trying to demonstrate that thing A causes thing B, okay? I need some way to change A up and down, manipulate A, and then measure what happens to B, right? So I get a data set in which A is the wage and B is the hours. I'm going to see what happens to B when A varies. Now, endogeneity, first, last, and always, well, okay, no, I don't want to make a global statement like that, but basically what endogeneity means is, so B is endogenous here, right, because it's generated by A in some way. It's determined in a manner that depends upon A. A is exogenous if the value of A, when high wage, low wage, isn't in some way either caused by B, reverse causation, or influenced by some third factor C, which also affects B. So in other words, A is endogenous if it is determined, generated, endogenous, if it is generated in the same system that generates B, either because B also affects A, or because there's some third factor C that affects both of them. That's the basic setup, okay? So endogenous means generated within the system. If A, or specifically the variation in A, high wage, low wage, is generated by circumstances in the real world that also affect B, or if it's generated in the real world by changes in B, then we have an endogeneity problem, okay? And just to give you one example of that, we saw a situation where we're looking at, in the same study, we're looking at the relationship between wages we're looking at a relationship between hours and wages where the wages were determined, were computed as earnings divided by hours, right? And so this is exactly, so this thing is A, this thing is B. We're trying to determine whether whether changes in this thing, the wage, cause changes in this thing. So we have an absolutely classic, very familiar form of endogeneity. We don't actually think that the number of hours you work each day affects your wage, but this number, the hours you wrote down in your trip sheet, definitely determines the wage we compute, because we compute it using this number. Okay, so this is a case, in some sense, of reverse causation, and as a result, it's an endogeneity problem. Okay, how do we solve that problem? In this case, we use an instrumental variable, which is we use other people's wages on the same day, which are correlated with your wage. But there's lots and lots and lots of other cases of endogeneity that we've looked at. We have, in the LIST study, LIST wanted to know, does market experience cause the endowment effect to go away? And he looked at his data and he saw there was a relationship, but we couldn't tell. Is market experience making the endowment effect go away, or is the lack of endowment effect causing people to have more market experience? Okay, endogeneity. These two things are generated within the same system, so you got to solve that problem somehow. We've also talked about various different kinds of confounds. Now, endogeneity is a subset of confounds, right? It's one kind of confound. It's a large classification of different kinds of confounds. But frequently, we will see confounds that don't really necessarily answer to the name of endogeneity. So a good example is we look at the income effect in endowment effect studies, and we also look at the income effect in labor supply studies. And what we saw, we're trying to measure the role of changing someone's endowment point on the difference between willingness to pay and willingness to accept. Okay? But it turns out that there's something else that determines willingness to pay and willingness to accept. It's, I guess you could see this as a form of endogeneity, which is that how much money you have. The income effect in the standard model causes a change in willingness. It causes a gap between willingness to pay and willingness to accept. So if we see a situation in which your income changes and there's a difference between willingness to pay and willingness to accept, we don't know whether that difference between willingness to pay and willingness to accept was caused by our experiment or by the income effect. So it's a confound. Your experiment is confounded, right? In much the same way that Yosemite Sam used to be confounded a lot of the time. I don't know the answer because there's a confound. So we've seen a number of examples. Income effect is a confound. Simultaneous causation, as I just described in the list study. Measurement area error in this wage elasticity equation. There was selection bias in the cab drivers. What if it's just lazy drivers showing up on days when the wage is high? Selection bias is another form of confound, another form. If I thought about it hard enough, I think I probably would have to say that confounds and endogeneity are actually synonyms. So go through and make sure that you've sort of thought about all of the ones we've seen, both in the readings and in the lectures. Okay. Obviously, the whole goal of psychology and economics is to figure out key psychological features of human decision-making and then capture them mathematically. So one of the things you need to be sure you understand or know is what are the key psychological features that we have thus far incorporated into our mathematical models. And it's a relatively short list. We've looked at reference dependence, loss aversion, diminishing sensitivity in the value function, and diminishing sensitivity in the probability weighting function. So reference dependence, by the way, when people talk about reference dependence in behavioral economics, there's a tendency to assume loss aversion for sure, and there's also often a tendency to assume all of prospect theory. But reference dependence is a very specific psychological feature of how we respond to stimuli, which is simply to say that we compare a stimulus to a reference point instead of just taking its absolute value, okay? Or it's a magnitude. Yeah, it's not its absolute value, but its size. So for me, the best example to sort of help me to remember what this really means in the abstract is temperature. Okay? Reference dependence does not mean, if it's like, let's say it's 70 degrees Fahrenheit, which it's probably only 75 in this room at the moment. Let's say it's 75 degrees in here, and we've all become acclimated to that. That's our reference point. Reference dependence does not mean that if the temperature went down by 2 degrees, we would feel that more strongly than if it went up by 2 degrees. It simply means that our ability to distinguish a 2-degree difference relative to 75 degrees is greater than our ability to tell whether or not it's 75 degrees. If the temperature went down to 70, I mean, there's a range for human beings, somewhere between sort of, I don't know, sort of 65 and 75, where we don't care very much what temperature it is. We don't really notice once we're used to it. But even in that range, or I could say there's a range of temperature, low temperature, if it was 0 degrees Fahrenheit, right? We might be indifferent between whether it was 0 degrees for the 80 minutes of this review session or 2 degrees. We might not be able to tell you, oh, no, this is 0, this is 2, or if we got used to it, oh, no, really, please turn it up 2 degrees. But we would feel a change of 2 degrees. Okay, so reference dependence doesn't assume loss aversion. It's this very, very fundamental psychological phenomenon. Then we've heaped onto that some more specific observations, one of which, the first of which, and I would say the most important of which, I think, is loss aversion. Okay, so we've seen it over and over again. It just drives a lot of things. Hopefully by now you understand what that means. Then we've looked at a couple of others. When we started to look at gambles, we added in a couple of others, because the gambles helped us to identify these features in economic choices, which we couldn't otherwise have necessarily observed without the uncertainty. So we threw in diminishing sensitivity as a general psychological phenomenon, right? We notice an increment of change more at first as we begin to move away from our reference point than later on when we're already at some distance from that reference point in any direction. Okay? So diminishing sensitivity, and we actually, psychologically, we think of diminishing sensitivity as being basically the same psychological phenomenon, how we perceive stimuli, whether we're talking about values or probabilities, whether we're talking about actual consumption levels, or whether we're talking about changes in probability. So the overweighting of small probabilities and the certainty effect, which are mathematically features of this probability weighting function, are also examples of diminishing sensitivity. It's exactly, well, I'm not a psychologist, so I shouldn't speak, but I was taught to think of that as a non-psychologist behavioral economist as being psychologically basically exactly the same phenomenon of diminishing sensitivity as the convexity we see in the value function, right? Because a 1% increase in probability matters to us much more. We notice it much more when it's the first 1% away from something definitely not happening, when it's the difference between 0 and 1%, than when it's the difference between something being fairly likely, let's say 42%, and still fairly likely 43%, which most people just write off as unimportant. And similarly, the first percent of something being of something that was so the first percent of something not being certain, we also feel more than a decrease in certainty further down in the range, right? So that's the certainty effect. Taking something from 100% down to 99% matters a lot more than taking it down from 43 to 42. Same psychological phenomenon as the convexity on both sides of the kink in the value function. Convince yourself that those things are the same. Any questions about that? Okay. Never mind. Okay, we talked a little bit about positive. Well, I've talked a lot about positive versus normative concerns and how that relates to the scientific process. So one category of things that I've talked about a little bit is situations where we've changed the standard model to make it predict things better, and as a result, we found ourselves in that wombat swamp in normative terms. Okay. So I actually talked about this more in the first sort of week and a half than I have since. But I talked about problems that arise with contingent valuation surveys and the difference between willingness to pay and willingness to accept, in which we actually believe is relevant normatively. Should we take seriously that people have loss aversion if we also know that they're going to get used to the loss and their reference point will adapt? Huge normative consideration. Why is that normative? Because it's about judging things as good or bad, placing values on things. How much value do we place on these trees, on this marshland? Similarly, in the same lecture, I talked about issues having to do with the Coase theorem, whether or not we give property rights to the owner of a swimming pool or the owner of a high-rise building. I talked about labor income sub-optimization, right? If people have this reference point, a model with a reference point, a target income, will predict their labor supply behavior much more effectively than a standard model without an income target kink. But then we have to ask ourselves, do we really believe that when people are maximizing their kink utility function, they're actually doing what's best for them? Because over and over again in standard economics, and indeed, this is, I would argue that this is almost the point, this is what makes standard economics standard instead of behavioral, is that under what we call standard assumptions, we get to say that an individual maximizing their utility is doing what is best for them. And then we get to measure how much they like it in terms of how much money they're willing to exchange for it